Not all cars are powered the same way. Some burn fuel, others use electricity, and some use both. Today, we'll break down the main types of engines used in motor vehicles, how they work, and where each one is best used. Welcome to the Automotive. Understand the car, not just the noise. Don't be left behind. Hit that subscription button below for more updates.
A petrol engine converts fuel into mechanical energy via internal combustion. Key components include spark plugs, which ignite the air-fuel mixture. Cylinders house the pistons, where combustion drives movement. Fuel injectors spray fuel into the cylinders for combustion. The petrol engine cycle includes intake, compression, combustion, and exhaust strokes. The intake stroke draws the air-fuel mixture into the cylinder. The compression stroke compresses the mixture, raising its temperature. Combustion ignites the mixture, forcing the piston down and producing power. A real-world example of a car using a petrol engine is shown. This provides context and relevance to the concept. A sports car could be used as an example. Diesel engines differ significantly from gasoline engines in their design and operation. A key difference is the absence of spark plugs in diesel engines. Instead, diesel engines rely on compression to ignite the air-fuel mixture. Air is compressed to a high degree, raising its temperature significantly. Fuel is then injected into this hot, compressed air, causing immediate combustion. This process results in a more efficient and powerful combustion cycle. Diesel engines use compression ignition to combust fuel. Air is compressed, raising its temperature significantly. Fuel is injected into the hot, compressed air. Precise fuel injection timing is crucial for efficient combustion. Diesel engines are commonly used in vehicles like trucks and SUVs. Diesel vehicles are designed for practical, heavy-duty applications. Diesel engines provide high torque, useful for hauling and towing. This makes them suitable for commercial and recreational purposes. An electric vehicle's powertrain includes the battery pack, motor, and power electronics. The battery pack stores electrical energy to power the vehicle. Power electronics control the flow of electricity between the battery and motor. The motor converts electrical energy into mechanical energy to drive the wheels. Electric cars represent a shift towards sustainable transportation. They are designed to operate without emitting exhaust fumes. This zero-emission capability helps reduce air pollution. Electric cars often feature modern and aerodynamic designs. These designs improve efficiency and extend driving range. Electric vehicles offer a cleaner alternative to gasoline cars. A hybrid engine combines an internal combustion engine with an electric motor. This system also includes a battery to store electrical energy. The electric motor assists the combustion engine, improving efficiency. The battery can be recharged through regenerative braking. This combination reduces fuel consumption and emissions. Hybrid engines offer a balance of power and environmental benefits. Hybrid systems combine electric and petrol power for optimal efficiency. The system intelligently switches between power sources. Electric power is used at lower speeds for efficiency. Petrol power assists during acceleration or high-speed driving. This switching maximizes fuel economy and reduces emissions. The animation demonstrates the seamless transition between power sources. Hybrid cars combine gasoline engines with electric motors. This combination enhances fuel efficiency. Hybrid technology reduces overall fuel consumption. Lower fuel use translates to fewer emissions. Hybrid cars offer environmental advantages. The animation displays a rotary engine in operation. It highlights the engine's unique triangular rotor design. The rotor spins within a specially shaped housing. This design contributes to the engine's smooth power delivery. The animation showcases the distinct operational characteristics. Two-stroke and four-stroke engines differ in their combustion cycles. Two-stroke engines complete a power cycle in one crankshaft revolution. Four-stroke engines require 2 crankshaft revolutions per power cycle. These engine types are used in different applications based on power and efficiency needs. Engine comparison charts summarize the advantages and disadvantages of each engine type. These charts provide a structured overview for informed decision-making. Key factors often include efficiency, power, and maintenance costs. Comparisons help users select the optimal engine for specific applications. Subscribe for more content and in-depth analysis of engine technologies.